So I'm going to do a quick lecture over just central processing, and then we'll get into the motor results or motor activity in the last lecture. There are two basic columns or tracts that the nervous system uses to send information or to determine what information has to occur. And so processing occurs either depending on if it's above the neck or below the neck. The information is going to be moved via the cranial nerves. Some of that information is going to, or the majority of that information moves to the thalamus, and then if it's something that we have to be aware of, it's going to move to the cortex. Whereas some information through the somatosensory area below the neck moves through sensory pathways of the spinal cord. So here are the two sensory pathways of the spinal cord. You can have either the dorsal column system or the spinal thalamic tract, depending on the type of information. So touch and proprioception, so joint movements, occur in that dorsal spinal system, whereas the spinal thalamic tract is going to take in information from pain or from changes in temperature. This is called the homunculus, and you've probably all seen something like this, meaning little human, and it basically shows the amount of the cerebrum that is associated with any sensory portion of the body. So if you are looking at it and it looks kind of funny, that reason is because your hands are very sensitive, so it shows your hand has a lot of information that comes in. The thumb specifically has a lot of information. Your face, eyes, nose, lips, these are all very, very sensitive. The tongue has a large portion of the cerebrum. Areas that you might not realize don't have as much information. If your hand has a lot of information, you would think your foot would too, but it doesn't. Your genitals, a lot of people think, oh, that's the most sensitive part of the body. Well, it's not. It might have some important sensitive functions, allowing us to procreate or allowing us to want to procreate, but it's not very sensitive. Not when you're thinking about all the different sensations that occur. So let's look at each of those basic senses again that we talked about already and see what happens or where central processing occurs. For olfaction, we don't really have to move to the thalamus. The thalamus doesn't influence our sense of smell, so the information comes directly from those olfactory nerves and moves to the temporal lobe for central processing. And that allows us to take in and smell things very rapidly. And we also forget or we adapt very quickly. For taste, the facial and glossopharyngeal nerves are going to send signals to the thalamus, and the thalamus will then send signals to the cerebrum. Apologies, I'm going to be done shortly, and I had an alarm going off. The thalamus will then send the signal to the cerebrum for us to perceive that taste. For hearing, again, we have the vestibulocochlear nerve that's going to, the vestibular section of the vestibulocochlear nerve is going to send signals to the thalamus. The thalamus will then pick up that information, send it to the cortex, temporal lobe, for conscious perception of sound. And then for equilibrium, again, the vestibulocochlear nerve, the vestibular section of the vestibulocochlear nerve sends signals to the thalamus, but it also sends signals to the cerebrum, or not cerebrum, I'm sorry, cerebellum, so that not only are we getting information to the cerebrum, knowing that, hey, we're moving, but now we are going to be able to coordinate the eyes and our head so that we don't get dizzy. here we have the vestibulo-ocular reflex. As movement occurs for our head, our eyes are going to recognize a specific region. They're going to move to whatever that region is, and they're going to focus on that region, allowing our head, though it moves, our eyes stay in the same spot and we don't get dizzy. So if you've ever seen someone spin, if you've ever been in a dance class, or if you've seen someone spin on ice, if you've been an ice skater, you know that you have to focus on one spot and then you just keep spinning, and because your eyes are focused on one visual spot, your brain or your cerebellum is going to help you maintain equilibrium the whole time. The last special sense we'll talk about then is the optic nerve, or is sight. And so with sight, it's a little bit different because we have two optic nerves that run to a region called the optic chiasm. And at the optic chiasm, the information is then going to converge together, and some of that information from the right optic nerve is going to move to the left side, and some of the information from the left optic nerve is going to move to the right side. And so in the end, we have information from both eyes moving to both sides of our occipital lobes, where we then can perceive one single picture. And again, this is that sensory homunculus, just showing the information. The motor, or I won't say that, the motor cortex, so movement, has a similar homunculus, but I don't have that homunculus, so I'm showing this one because we're going to get into motor response next, okay? So I'm going to stop here. Like I said, the last video will be on motor response, and I'll be posting that one shortly. Bye.